Okay, let's get started. So, hello everyone, and thank you for joining us today. This is going to be the first in a four-part webinar series that is going to dive into each of the four domains of the AWS Certified Solutions Architect Associate. Now, the aim of this series is to give you more of a guided understanding as to the sort of topics and areas that you should be familiar with when studying for the exam. Now, if you have any questions as we go through the webinar, please use the chat window to submit them, and we will do our best to get to as many of them as we can as we get to our Q&A section towards the end. Now, firstly, let me introduce ourselves on the panel. With me here today, I have Will Meadows, who is a senior content creator here at Cloud Academy. And now, Will previously worked for AWS within their training and certification department, and he primarily focused on creating courseware around AWS architecture. So he's a great fit for the webinar today. So hello, Will. Thank you for joining me today on this call.
Yeah, hello everybody. I'm excited to be here.
And of course, myself, I'm Stuart Scott, the AWS Content and Security Lead here at Cloud Academy. So let's take a look at the agenda for today. I'm going to start with taking a look at the AWS Global Architecture. It's a really important point, and we really need to pay particular attention to this because you need to be aware of the differences between availability zones, regions, and edge locations, because many of the questions will be focused around this, and it will help you interpret and understand those questions where these terms will frequently appear throughout the exam. And then following this, we're going to be breaking down each of the four subdomains. So designing a multi-tier architecture solution, designing highly available and or fault-tolerant architectures, decoupling mechanisms using AWS services, and choosing the appropriate resilient storage. Now, in domain one, just before I go, it does equate to 30% of your total score. So it is worth paying particular attention and putting in the extra effort for this domain because it is the largest percentage domain. So let's start with the AWS Global Architecture. Like I say, it really is key to have a good understanding of this when you're taking the certifications. Now, as a recap for the availability zones, that are simply multiple physical data centers that belong to AWS, and this is effectively where all their hardware resides for all your compute, storage, networking, database, etc. Essentially, where the resources that you provision within AWS physically exist. Now, the availability zone itself will contain more than one data center operating just a short distance from each other within a localized area. And then this collection of data centers will form a single availability zone. Now, each availability zone is then connected to at least two other availability zones using low latency and highly resilient fiber connections. And then when you have multiple availability zones connected, they are then considered a region. And these AZs forming the region are sometimes all within the same city. For example, we have regions such as London, Milan, Sydney, Beijing, etc. So moving on to regions quickly. Do you have anything else to add on availability zones, Will?
Yeah, I think one of the important things to remember about availability zones is they're also geographically on separate planes, usually separate by 50 miles as far as I can. So for like the London one, they'll probably be on the opposite sides of the city. So that way they're not like, if a flood was to happen or some other strange natural disaster, it wouldn't take out the whole AZ easily.
Excellent, good point. So let's now move on to regions. Now, the region is simply a collection of availability zones that I just explained, and there are regions all over the world. So, and this helps to allow AWS and its customers to really build a global presence. The regions themselves, they act independently from all other regions. And I think at the moment there are 24 different regions, but this number grows every year. I keep seeing announcements that new regions are being released by AWS.
Yeah, it's constant. The AWS spends a lot of time and resources globally trying to build up the infrastructure to help you push your data out to your customers wherever they may be.
Yeah, I think the last one was Milan, wasn't it, recently?
Oh boy, that's a tough question. They keep changing, they keep adding more.
Oh, well, let's move on to edge locations. So yes, finally, edge locations. Now, these are deployed in major cities and other highly populated areas world over, but they differ from availability zones in the fact they are used by AWS services such as AWS CloudFront to cache data and reduce latency for end user access. So they don't act as a data center for your resources that you can provision in. As I mentioned, edge locations are used heavily by CloudFront, and that's AWS's own content delivery network, its own CDN. Okay, so that's three very different components of the global infrastructure, but you need to understand each of them and how they differ, because without that knowledge, you will begin to struggle when it comes to understanding how to correctly architect your solutions. Any final thoughts on the global infrastructure, Will?
Yeah, it's to keep it all simple. Amazon has data centers. These data centers sit inside availability zones. These availability zones sit inside regions. And then edge locations are the strange sort of stepchild that you don't get to talk with directly, but they're there to help push out content to your customers at a quicker rate than maybe a region can.
Sounds perfect to me. So let's dive into the first of the four subdomains of domain one, which is design a multi-tier architecture solution. So let's look at the kind of things you need to be aware of when being assessed on this point. So firstly, what is a multi-tier architecture? Do you want to answer that, Will?
Yeah, so those of you who sort of come from a software development background may be familiar with like the model view controller sort of idea, where we're separating our working pieces into more than one part. So we're not a huge monolithic thing that can fall apart as easily, and allows us to secure different parts of our architecture with more security or less security where needed. So for example, here we have a three-tier architecture with the web tier, the app tier, and the data tier. And what that allows us to do is split up, as I spoke of before, our database from our software and then from our web. So that way, if one goes down, the whole thing might not go down. And you see here on this visualization that we have something called a public subnet, we have something called a private subnet, which we can discuss here in just a second, actually.
Yeah, definitely. And also having those different tiers, it allows you to localize in those subnets, just focusing on specific tasks. And by having those specific tasks, it enables you to implement those more secure and granular controls at the boundaries of each tier, which is really good. So a question here, what are the benefits of the tiered infrastructure? Well, it helps to hide internal networks. By having that public facing tier, access is denied to all of the other private tiers. And this helps to offload tasks to other networks as well. But like you say, one big benefit is the security aspect of it. So you mentioned about the private and public subnets here. So let's dive into the virtual private cloud architecture. Firstly, what is a VPC? It's essentially your own isolated segment of the AWS cloud itself, and no one else will be able to access it by default. It's totally isolated for your own account. And then once you have your VPC, you can start to deploy resources in it. One thing to bear in mind is that you can only have 5 VPCs per region per account. And when you create your VPC, you need to define a CIDR block, which is effectively an IP address range for all of your resources that you will have within your VPC. So make sure when you're creating your VPC, you give it a big enough CIDR block. And this IP address range, I think it can have anything from a /16 to a /28 mask. Correct me if I'm wrong there, Will, but I think that's correct.
Mm-hmm.
So once you have your VPC, you can then start creating your public and private subnets. Do you want to run with that, Will?
Yeah, so now that we've got a little bit more information on the screen, a public subnet and a private subnet they're kind of exactly what they sound like at face value. Public means anyone can sort of have access to the things in here. So you'd really only want to put stuff that you're okay having public facing, where someone could hammer on it or try to break into it, and you'd be all right with that. I mean, it's not great, but it will do. And on the private side are things that you definitely want no access to the internet whatsoever. like your application layer, probably your database layer. And in AWS, it's a rather simple sort of nomenclature of what makes something public or private for a subnet is, does this thing have access to an internet gateway? And does this thing have a route out to the internet gateway with its route table from that specific subnet? And so you can see here in the web tier, we have a route table entry that's all 0/0 out to the internet gateway. That means all traffic that's not directly routed is going straight out to the internet. And vice versa, if traffic wants to come in, since this is a public subnet and has access to the internet gateway, your customers can hit these web servers up front. Everything in the back, though, does not have direct access to that. Now, you might be asking, how can I get internet access to these things but not let the rest of the general public have that privilege? Well, back in the olden days, you could use something like a NAT instance or a Bastion host, but we've got a cool thing for AWS called a NAT gateway. And this is a fully managed thing that you don't really have to deal with, which is super nice that Amazon will set up for you and deal with the scaling. So that way your backend instances have a way to get out to the internet, and it's sort of one-way traffic.
Yes, it's definitely a pretty cool device.
It's so nice.
and just one thing as well, going back to the public and private subnets, what I get asked quite frequently is what makes a public subnet a public subnet. And like you say, you need that route table, you need that internet gateway. When people start using AWS, sometimes it's almost like they're looking for a tick box when creating a subnet to say, well, how do I make this public? You know, is there a tick box to say, I want this to be a public subnet?
Exactly.
The creation of the subnet is exactly the same. It's how you then apply different configurations to that subnet that makes it a public subnet or a private subnet. So that's just one thing.
That is definitely a question that's going to be on the test if you're thinking about looking that way, is what does make something public or private in AWS? And just to reiterate, does this thing have a route out to the internet?
And does it have an internet gateway?
Yes.
Exactly. So in this diagram here, there's an internet gateway attached to the VPC. You can see in the top right, but only the public subnet has that route pointing to the internet gateway. The private subnets do not. So although there's an internet gateway there, the private subnets don't know how to get to it without that route, which is why it's private.
Yeah, and to send your private traffic out through the NAT gateway, it would just be a route table pointing directly to the ID of the gateway. And then from there, Amazon will take it away.
And that's great when you need to maybe perform patch updates on your EC2 instances in your private subnets, because obviously you need access to the internet to do that. So a NAT gateway is a great way to access the internet. And one other point as well to make with a NAT gateway, it doesn't accept any inbound connections being initiated from the internet. So that's how it protects your resources as well.
I have a fun question for you, Stu. How does this all work with IPv6?
IPv6? Why did you ask me that?
Well, it's because I want to talk about it. It's one of those fun things. So the deal with IPv6 is you have to use an egress gateway, or sorry, was it egress routing gateway? So it's only outwards. IPv6 is very strange, and that's another question you should look for on your test, is the difference between how do you get traffic in and out in IPv4 versus IPv6 for your VPCs. And you can actually live in both modes at the same time, which makes things even more confusing.
Which always helps.
Exactly.
So moving on to NACLs and security groups. So a NACL is a network access control list, that's what it stands for. And it's a security control that's implemented at the subnet level. And these are essentially virtual network level firewalls, you can think of them as, and they're associated with your subnets in your VPC. And they control both inbound and outbound traffic moving in and out of your subnets. One point to remember is that you can only have one NACL associated with each subnet, and the default NACL that is associated allows all traffic in and out, so it's not very secure at all. So it's always good to have your own custom created NACLs. Also, they are stateless as well. That's another thing that might pop up between NACLs and security groups. NACLs are stateless and security groups are stateful. So whereas NACLs control security at the subnet level using port and protocol, Security groups, they're very similar in their operation, but they work at the instance level. And then, like I say, they're stateful by design.
Now we talked
With
about the
Yeah, sure. Go on.
statelessness. I know this could be confusing for me when I was first learning. What that means is for the stateless NACLs is if you say something is allowed on port whatever, it doesn't automatically mean that incoming and outgoing traffic are allowed. You have to explicitly tell it that. You'd have to make 2 rules for that. While in a stateful thing, like a security group, if you just say this traffic is allowed, it will automatically change that for you. It does both inbound and outbound.
Yeah, very good point. Okay, so let's move on from VPCs and let's focus on elastic load balancers. So, what is the main function of an ELB, and when should you use one?
Oh boy, ELBs are the greatest thing since sliced bread. They basically allow you to have thousands and hundreds of connections coming in and equally distribute it, plus or minus, to your available instances into your architecture. There are a few flavors of the ELB. I don't like to talk about the classic one because in general, you won't use it at all unless you have a very old architecture from like 6 years ago. Amazon doesn't really deprecate anything. They just hide it away so you can never use it again, but it's still there just in case. The other two, however, we'll start with the network load balancer, is operating on, I believe, layer 4. It's at the connection level. And
Yes,
the network load balancer is the load balancer you want to use when you need throughput, you need performance. My God, there's so much traffic, I don't know what to do. This is the one you kind of want to go with. It's not very smart though. It basically just shuffles out the cards as best it can. If you're looking for a little bit better routing and some interesting logic behind it, you can use the application load balancer, which is it runs on the application level. And it allows you to do some really fun, smart routing. So let's say you had I don't know, michaelwebsite.com/API. If you had that come in as your request, it is able to shuffle off to a specific instance based or a pod of instances based on that URL, which that is super like fascinating to me. Hopefully it's cool to you.
Of course, of course.
So that's the high level on those guys. Stuart,
Yeah,
you
so you
so
definitely need to know the differences between the application network and the classic load balancer. And just also bear in mind as well that ELBs can span across availability zones within a region, but not across regions. So there's a number of components to the elastic load balancer that you should be aware of, and understanding the differences between these will help you answer any questions that come up on the configuration of these. So you have the listener, which defines how your inbound connections are routed based on different ports and protocols. The target group, now this is essentially a group of resources that you want your ELB to route traffic to. So it could be a fleet of EC2 instances, for example, and that's defined as a single target group. You can configure your ELB with different target groups and associate each of them with a different listener configuration, and each of those with different associated rules. So this enables you to route traffic to different resources based on the type of request you're getting, basically. And then, sorry, I just dropped my mic. And then you have your rules. Now these are associated with your listeners. So again, these help you to define how an incoming request gets routed to which target group that you have. And then finally, health checks, which allow the elastic load balancer, depending on which one you have, to contact each of the targets using a specific protocol to then receive a response. If it doesn't receive a response within a set time frame and set of thresholds, then the elastic load balancer will mark that target as unhealthy and stop sending any traffic to it. So what's the difference between, sorry, welcome.
I still have one question here at the bottom is, what's the difference between an internal facing and I think it's supposed to be external facing load balancer. So that's internet facing, yeah. That's a good question, and they're pretty much exactly the same, just that their function might be slightly different. Your external facing load balancers are public and would probably be routed to from DNS from Route 53, which is the Amazon DNS service. Yeah. And then an internal one would be sending as you can see in this example, information or traffic from one tier over to another tier and to balance it correctly.
And it's pretty much as simple as that.
Yeah, it is.
One's external with a public IP address and the other one's private. Only accepting requests internally in your VPC.
Yeah, that would be a fun trick question on the exam if you were to take it. It's, they're pretty much the same, just about where the traffic comes from.
Okay, so let's look at auto-scaling. So what is it, and what are the kind of benefits and advantages? Well, auto-scaling basically allows you to increase or decrease your resources to meet the demands of your applications, which are based on different metrics and thresholds. It helps you to optimize the cost of your EC2 fleet because you only pay for resources when they're running. So you don't want to be running lots of compute resources if the demand isn't there. So auto-scaling can help you scale those back. It's an automated service, so there's no manual scaling or provisioning from your support teams. And also it can ultimately lead to greater customer satisfaction by always having enough resources available. You won't have customers kind of waiting on the end, waiting for resources and pages to load, etc. So one thing that comes up frequently is knowing the difference between scaling up and scaling out. Now, when you scale up, you are increasing the compute power of your instance. For example, you might be going from an M3 large to an M3 extra large or to an M3 2 extra large. When you scale out, you add more instances of the same type. So going from maybe 2 M3 larges to 3, 4, or 5 M3 larges. So just be aware of those differences. Sometimes you might need to scale up your instance, and sometimes you might just need to scale out. So what is a launch template and what does it comprise of? So again, make sure you have hands-on experience of auto-scaling and creating launch templates in groups. With the launch template, it simply defines how an auto-scaling group can provision your new EC2 instances when you need to scale out. They outline the AMI to use, the instance type that should be used, if you need a public IP address, the storage volume configuration, security groups, etc., etc. Whereas the auto-scaling group defines the desired capacity of your scaling and other limitations using different scaling policies which identify which availability zones that they should scale into. So take a look at auto-scaling, play around with it, create an auto-scaling group, create a launch template, and just become familiar with the different types of configuration options that there are. And should you use elastic load balancers and EC2 auto-scaling together? What would you say, Will?
100%. That is like the bread and butter of like all of this test. I was waiting for this moment. So when you take the test, there's going to be a bunch of questions about minimum capacity needed. So if you have 2 AZs and you have an auto-scaling, or if you have a load balancer that's distributing between the 2 AZs, you would have an auto-scaling group in both of those. And it will ask something like, what is, let's say your SLA is like, you must always have 2 instances running at a time, no matter what happens. And what if one AZ goes down? It's like, well, your auto-scaling group should be set to a minimum of having 2 instances in each AZ. That's a total of 4, but that way if one AZ goes down, you've met the minimum SLA of having 2 instances running. So these guys work in concert, something, all the time. It's going to be on the test a lot if that's something that interests you. I think something also that's fun to talk about with auto-scaling is there's like 3 different flavors of it. And there's many ways you can get around it besides thinking about the current CPU demand. So you could think about scaling based on time. So if you know that your company, let's say you're the IT guy, starts dev work at 10 a.m. in the morning and ends up closing out at 6, you could spin up all your dev devices on a timer and tell it to run during this time and then close out at end of business. So maybe you're only using a third of the total cost as you would normally, since you've scaled based on that. And the other auto scaling options you have is you can scale on CPU, which is the pretty obvious one, but you can and hard code those rules in. But we also have a really cool machine learning based autoscaling where it will watch your base autoscaling over time and to see what your needs are, and eventually it will start guessing and increasing the number of instances that you have in your pool all by itself.
That's pretty cool.
Very interesting. And oh, babies, sorry, this is also important. If you want babies first self-healing group, you can set your auto scaling minimum to 1, and let's say you only have 1 instance, but this instance needs to always be up. If it hangs or freezes, the auto scaling group will kill it and then respawn a new instance of that type. And it's a self-healing architecture, which is something that's also going to be on the test if you decide to take it. Sorry, more rambling. Go on.
Rambling's good. It's all these little nuggets of information, which is always handy. Okay. So on to 1.2, design highly available and or fault tolerant architectures. So you need to understand high availability and fault tolerance. So what's the difference between HA and fault tolerance? Now, I looked into this because there's lots of conflicting information. A lot of it sounds the same. And I found a quote by AWS that defines fault tolerance as the ability for a system to remain in operation even if some of the components used to build the system fail. So this means that there should essentially be no loss of data or functionality. So for example, if you built an application using EC2 instances with persistent EBS storage volumes, and then the EC2 instance failed, the application stored on the EBS volume would remain intact, and that could simply be reattached to another EC2 instance to resume the operations. Now, high availability could be looked at in the terms of the AWS Global Infrastructure that we spoke about earlier. Running your applications across multiple availability zones does help to maintain a high level of availability. Now, should an AZ fail, and it has done in the past, your application should maintain its operation and still be available. So it's they're kind of very similar concepts, but you just kind of need to be aware of them. And again, having a solid understanding of the global infrastructure that we spoke about earlier will really help you answer any questions within this part. Why use multi-regional deployments? And there's an example on the screen of a multi-regional deployment with multi-region architecture. Or there's a
lot on there.
There is a lot on there. It's just a graphic to show that there's a primary region and then there's a secondary kind of failover region as well, or there might be active. But why use multi-region deployments? Well, there's a number of different reasons. Firstly, you might want to do this for DR purposes. Should a catastrophic event occur that destroys an entire region, I don't think that's ever happened as yet. I could be wrong.
Not yet.
But fingers crossed, let's hope it doesn't happen. But if it does take an entire region out, then you could still operate your services on your secondary standby region. Another reason could be to improve latency. So if your customer distribution for your business is worldwide and you have customers across the globe, then running your infrastructure from multiple different regions across different cities of the world will help you maintain a low level of latency from your global customer base. And another reason could be compliance. You might need to meet specific data compliance rules that dictate that data has to stay within a specific region. Do you have any more comments on that, Will?
That one's particularly important, that your customer data must retain within its certain geographical boundaries and it can't spread. So if you deal with retaining people's data, that is your compliance department should really chat with you about making sure it's staying where it's supposed to, because otherwise you can get in trouble. But those are the big ones. Yeah, I think especially for gaming or anything that's user focused, that having your regions as close to your customers as possible is best, and something you should really think about when designing your architectures.
Definitely. We also need to cover database high availability as well, because this is something that crops up in the exam. You need to be aware of RDS multi-AZ. If you're not familiar with that, it stands for multi-availability zone. So with multi-AZ, a secondary RDS instance will be provisioned within a different availability zone within the same region as the primary instance. And its primary purpose is to simply act as a failover option for your primary RDS instance. What are the differences between primary and secondary instance? Well, the primary is used as a source for all reads and writes, and the secondary just kind of sitting there and waiting, basically, to be used. It has data replicated, I think it's synchronously. Yep. The replication between the primary and secondary happens synchronously. But the primary goal of the secondary instance is just to act as that failover. Anything else to add to that, Will?
Failing over is interesting because that usually involves, it's not as easy as it sounds, as AWS would like to make you think, but it is not terrible. A lot of the failover and routing in regards to that you'll have to do through Route 53 and to make sure it fails over gracefully. So that's something to look into, and that might be a question on the test if you were taking it.
Yeah, so RDS makes all the DNS changes by itself. Updates the DNS records now to point to the secondary instance in the secondary AZ.
Oh, I love it when they make improvements.
Yeah, it takes between 1 and 2 minutes for that change to happen.
That's the thing. If anyone tells you they know everything about AWS, they're lying to you, because AWS changes like 1,000 things a year. So.
So what circumstances does a failover occur? There's a handful of different instances when a failover will occur. If you're having patching maintenance done on the primary, then traffic will move over to the secondary. If the primary database has a host failure, then again it will move across. If the availability zone of the primary database fails, then you will have your secondary database to take over. So again, AZ failures have happened within AWS, so it's certainly something to bear in mind. If the primary instance is rebooted with failover, then that will be considered a fault on the primary. And lastly, if the database instance class on the primary database is modified, and then while that change is happening, all operations will move across to the secondary instance. Lastly, how is the...
It's nice not having to do all that yourself anymore, and just in general. Like, that's the one cool thing about using managed services, which this is one of, is even more and more AWS is taking on the burden of making the hard stuff easier. So
there's going to be less and less of us to do.
Yeah, I mean, can you imagine doing all of that, running a database on an EC2 instance? That would be kind of nuts.
Yeah, not for me. So that last question there, how is resiliency managed through Aurora DB?
There are so many copies of your data for Aurora and 3 different AZs within a region. And even if you find a region that doesn't have 3 AZs in it, which is rare, there's a hidden shadow AZ that you don't have access to that is literally just there for Aurora. So it's really cool. And it's also a cloud native database engine. So it helps deal with scale and the velocity of your data, which is a fun term, really well.
Cool. Yeah, so if your primary instance fails on Aurora, then one of the kind of replicas in the other availability zone will be promoted to the primary, which is pretty cool. Okay, elastic IP addresses. What is an elastic
network? That's really this question. So yeah, elastic IP addresses, you really won't use them yourself that often unless you're doing sort of HA on a shoestring budget. It's used a lot in many other services behind the scenes. So I guess I should describe what it is first. So an elastic IP address is like any other IP address you would imagine. It has numbers and such, and you can route to it. But you can move its target. So let's say you had 2 instances, you have instance 1, instance 2. You can change the directionality of routing from one to the other solely by using this elastic IP address. It's bindy, it moves wherever you want it to.
And it's a public IP address as well.
Oh yes, that's right. Those are important things to tell people. So when should you use an elastic IP address? I would say if you're doing this now in the modern times, I don't think you're designing architectures in the right way, but you could use it to have sort of a failover hot standby. Let's say you had one instance that had all of your cool software on it, and it went down, but you had some like a Lambda function to quickly reroute this IP address. You could switch it to another hot standby and route all your traffic to that.
It just helps to mask the failure, doesn't it?
Yeah, yeah. But realistically, you could have an auto scaling group just build a new instance for you and use that instead. So here's what I was going back to is things that use elastic IP addresses behind the scenes. So this, though you have access to it, is really just used by AWS a lot. So like our NAT gateway, for example, must have an elastic IP address, and it steals one of them from you for a time. And you can't get rid of it or get it back until you delete the NAT box or the NAT gateway, excuse me. So little interesting thing behind the scenes there.
Yeah, another cool feature of the EIP as well is when it is associated to an instance, if you stop or restart that instance, you'll have the same public IP address. Whereas if you just associate a pooled public IP address to an instance and then stop or restart that instance, you'll have a different IP address. So
Yeah,
it's a good way to maintain a static public IP address if you need to.
That's true.
How many EIPs can you have? I think it's 5 per region.
Yeah, they're very generous. You only get charged for them though if you don't use them, which is funny.
Yes. Yeah, so you can provision them, and if you don't use them, you get charged, which is interesting. And then we have the Elastic Network Interface, the ENI. So the ENI is a virtual network card within your VPC. You can create, configure, and attach it to your EC2 instances, and the configuration of that network interface is bound to that ENI and not the instance that it's attached to. So this means the details are transferable between your instances. For example, a private IP address or an elastic IP address or its MAC address, it travels with the network interface. So when should you use it? You might have circumstances where you need multiple interfaces, like you can see in that image there. A great example of this is when you might want to create a management network. So you could use an ENI to attach to your instance configured with another private IP address to handle any management traffic from within a different subnet. So there's lots of different scenarios where you might need multiple network interfaces. And if you need to do that, you use an ENI.
They're also used very often in many other services, again, sort of behind the scenes, but sometimes you have to set them up yourself. So for a service like Global Accelerator, you have to shove these puppies in each one of your subnets that you wish to have access to Global Accelerator in.
Cool.
Just some fun trivia.
So 1.3, design decoupling mechanisms using AWS services. Let's start with SQS. What is SQS?
What is SQS? It's the simple queue service, I think, unless it changed.
It's
basically like any other queue you've ever seen in your life. You put things in a line, and then the things come out of that line sort of however you want them to. They can either come in successfully one at a time, but one of the fun features that Amazon offers is not guaranteeing the order of it depending on the type of queue you have. So if you have a standard queue, Amazon guarantees that your message will be delivered at least once. It could be delivered twice, so make sure you can handle that. But it can send a lot of them. A lot of messages can fly through SQS. And SQS is a managed service, and so it will scale and it will shrink as needed to deal with the amount of volume you use. Amazon also has a FIFO queue, which is if you do care about order when it's important, but it limits the amount of actual traffic you can send through it. I think it's up to like 300 messages per second, and then you can batch 10 messages per operation to get up to like 3,000 messages. That might have changed. Don't quote me on that.
Yep, it is. Yep, if you use batch. And FIFO, if people are wondering, that's first in, first out.
Oh, yeah. That is important to tell people. So that's for when you do care about the order and you want them to come in as they came. What else?
And also as well, the components of SQS. So you have a producer and a consumer. So the producer is responsible for sending messages to your SQS queue. And then the consumer is responsible for processing those messages within the queue. And that's pretty much the difference between the two. When the consumer has processed the message, it will then delete it from the queue as well.
But what happens if we can't process the message? Maybe it's got malformed information.
And then it goes to the dead letter queue.
Oh my, that's very impressive. So the dead letter queue is where all of your letters you try to open are unreadable or undigestible. They get thrown in a different queue, so it doesn't continuously block up your consumers from trying to chew through your workload. Something to be aware of. And then you can have another application read through those letters. You could look at them yourself to see if there's a common error. You can delete them, but that's probably bad idea. So we do have a cute example here about using SQS for decoupling. For those of you who are not familiar with decoupling means, or at least in this situation, it's trying to unweave a tightly coupled architecture. So if you had a bunch of things that must point to another thing in order to work, if one of those things breaks in that chain, your whole architecture just sort of falls apart and then it doesn't work, and that's bad. So how do you stop that from happening? Well, if you look here in the top little diagram I've got, you'll see an ELB, which is our load balancer, is shoving traffic into our web store. Think Amazon.com or whatever web store you like. So when someone makes an order, that order could become a message and can be thrown into the queue. And notice the queue lives up there in US West 2. It does not live within your VPC. It's friendly outside. And at some point later, from your private subnet, you might have an order processing instance that's chugging through those guys in order to put the orders out for delivery. And what's cool about this whole thing is if the back end goes down, it doesn't matter. Whenever it comes back up, it'll start chugging through. And what you could do as well is have an auto-scaling group that looks at the size of the entire queue, of the order queue, and really like poof up the number of instances that are there to help chew through it quicker. And then once that queue goes back down, you could pop the instances away, and then it'll be back to its normal capacity. So that's a very fun architecture right there for decoupling.
Nice, thanks for that, Will. It's good, good demonstration walkthrough. Okay, so moving on to SNS, again used in decoupling. So what is SNS? It's the simple notification service, and this is essentially a publish and subscribe messaging service, which is used to help automate notifications in response to events that occur throughout your environment. These messages, they're pushed to topics, which you can think of as a container, I guess, for collecting messages. So with your topic, you can then have users subscribe to that topic. Therefore, they will get notified of any messages or events that are published to that particular topic by your environment. When the message is published to a topic, then all subscribers of that topic will receive a notification of that message. And so this helps to implement event-driven and decoupled environments throughout your solutions. There's a number of different subscriptions. Actually, just before I move on to that, with regards to the topics, as an element of security around them, as you can see on the screen, as a topic policy, so you can control who can subscribe to that topic, and also who can push messages to that topic, and also the different kind of delivery protocols as well. So for every topic, you can apply a topic policy to add a bit more additional security. So again, it's another one of those services that you want to get a bit of hands-on with, set up creating topics, have a look at the topic policies, and just have a little play around with sending messages. A number of different subscription methods, as you can see on the screen. So again, just have a little play with those. Integrates with lots of other services that we have. Anything else to add on SNS?
Yeah. One fun thing to compare and contrast SNS and SQS is SQS guarantees your message will get there at least once, could be a bunch. SNS doesn't guarantee delivery, so that's something you have to think about, where maybe something gets lost in translation from email. It doesn't know if your email got to you or not. It just sends it out and hopes to God that nothing interrupted it or broke the flow. So something to think about for mission critical workloads, whether SNS is good enough for you.
It's a kind of send and hope service.
Yes. It almost always works.
Sometimes that's good enough.
Exactly.
So Amazon Kinesis, what is Kinesis used for, Will?
Well, kinesis, it used to be used for just a couple things, but now it's got a whole wide range of family members. Dealing with a lot of incoming data, you could kind of think of like kinesis as sort of your queue service, like SQS, but like on steroids. It does a lot now. It deals
For
with large flows.
real-time data, yeah.
Yeah, real-time data. So if you had a bunch of telemetry equipment out in the field, like let's say you're measuring temperatures or something, instead of like shoving that all into a strange queue where it would just build up like every second, you could just send that streaming data straight into Kinesis and do various things with it. Like you could perform analytics. You could, let's say you had video streams. You could help ingest, that's a lot of data too, sorry. And you've got all these various options for Kinesis now that allows you to deal with high volume streaming data in a nice way.
Yeah, it's definitely something you should be familiar with, and just be aware of the Kinesis family and kind of what each of those does, what data streams does, what Firehose does, video streams, data analytics. Just as a very, very high level on each of those. Data streams offers a real-time data streaming. It's highly scalable. It supports thousands of data feeds. It's great for creating things like real-time dashboards. Video streams, they're designed to ingest video on a massive and secure scale, and they can connect to millions of video streaming devices where it can then store, encrypt data ready for processing by your data analytics solutions that you might have. Data Firehose, this helps you to load streaming data into Kinesis Analytics or Amazon S3, Redshift, Elasticsearch, etc. And Kinesis Analytics helps you to write standard SQL queries on the incoming streaming data. So just be familiar with the different families that there are as well of the Kinesis family, because you might get a question on streams or Firehose, or you might be asked which element of Kinesis would be best to support a particular scenario.
And I know when I was first learning this, it was quite confusing, having 4 different things that sound exactly the same. So if you get the opportunity to read the white paper around Kinesis, I'm sure it will spread some amount of light, and you'll find that helpful.
Okay, so 1.4, which is the final subdomain, choose appropriate resilient storage. Do you want to walk us through this slide, Will?
Yeah, so what's the problem with ephemeral storage or the instant storage? I think I just gave it away. That's also on the slide. You have storage on your EC2 instances. These days, not as much of it is instant storage, but it exists. And this storage goes away. So if you had very important data on it and you wanted to keep that, it wouldn't be very resilient if it disappeared and didn't exist anymore. So things you want to do in order to keep your data is obviously put them in very resilient places, like S3. We haven't talked about it directly, but S3 is sort of object storage. It allows you to shove like a lot of data into it. I don't think there's a top end, but there's a top end for files.
Unlimited storage.
Yeah, I bet you could find it though if you were trying to break it. Just put all of the internet data in there, and then you've got something like Elastic File System, which is a file share that works across AZs, which is incredible. So if you were trying to, let's say, have 1,000 instances, all able to look at the same file system at one time, it wouldn't work with S3 because that's obviously object storage. And that's very hard to write out yourself to make as your own application. But luckily, Amazon has this network file share. I think it uses NFS, if I remember correctly. And if you don't need something that's that strong, you can use Elastic Block Store, which is an individualized storage, think of it like a hard drive, just for one instance at a time. And each of these have varying levels of resiliency, availability, and I guess applicability. If we take a look at the next slide, we can dive into them each just a little bit more. So you'll see there are a number of 9s. Amazon really likes to tout its number of 9s. It's very famous for it. So S3, I guess we should talk about availability versus durability. Availability is if you want the data, will it be there when you ask? Like, do you have access to it? And durability is when you do try to access that data, is it still like alive? So it's okay if something's sort of less available, like you don't have the ability to get it, as long as it's still there and you could get it eventually.
Yeah, so for example, if an availability zone went down, and you couldn't access it, when it comes back up, your data's still there.
Yeah, that's important. So if you look at S3, the standard storage class, it has 99.99% availability. You'll probably get it every time you ask, but it's durable as heck. 11 nines of durability. That's like, if I remember correctly, one file in 1 million files in 1 million years will disappear. So take that with you. That's a lot of.
That's pretty good.
But of course, it's object storage. So if you are running Photoshop or something, it won't work with S3. You have to basically resave over it every time. And in general, S3 works really well for architectures that are write once, read many. So like, let's say you have an image for a website, you want to shove that into S3 so it can get downloaded a bunch, but you don't really want to write over a whole lot.
Yeah, and just with S3 as well, just be aware of different storage classes that are available. Understand how S3 versioning works. And S3 lifecycle configuration. And I think if you've kind of got those nailed, you should be able to answer most questions regarding resilient storage on S3.
And EBS, again, is our sort of our one-to-one map hard drive for an EC2 instance. It's super available. It's got one additional 9. Its durability could be considered questionable. If you're using a standard EBS volume, it's like 99.9%. which sounds good, but can be scary if you really like your data. So think about doing snapshots regularly, which is a backup of that data, or, well, and those snapshots go into S3, so you know it'll always be there. I believe it's stored there. You could get the high durability volume, which dramatically adds another couple 9s to it, which is a lot. So things to think about.
And also as well with the EBS volumes, it automatically replicates those across multiple availability zones, which helps increase the resilience of it as well.
Exactly. And then again, talking about EFS, it's got some number of 9s. It looks very similar, as you can see, to the ones above. Its big shining crown jewel is that it is a shared file system in the cloud, which is kind of difficult to do sometimes. And it's designed to be massively parallel. Like I said, you could have thousands of instances, which is super cool. And it can be shared across availability zones. That is a very neat feature that I don't think you'll find with a lot of many other cloud companies. So it's something also that could be important for your workload.
Excellent, nice one. Thank you very much, Will.
Yeah.
So I think we have a couple of minutes left for Q&A. So let me just take a look to see what questions have come in.
We got some good ones.
Yeah, what's the difference between Elastic IP and the Elastic Load Balancer? Well, the Elastic Load Balancer is used to take any incoming traffic and distribute it between multiple targets, for example, an EC2 fleet. So it balances that traffic across your fleet of targets. Whereas the Elastic IP address is simply just a static public IP address that you can assign to different instances. It doesn't perform any kind of load balancing in any way. So they are very, very different components, essentially. Anything to add to that, Will?
No, that was fine. I think this is a quick one we can do. Can you explain more on how gateways handle public IP addresses? It's the same way that normal public IP addresses are handled for the internet. They get propagated through all of the border gateway protocol people, routers and whatnot that live on the internet. And it just travels right through the internet gateway the same way. So it's public IPs are public as long as they're within a public subnet that has access to an internet gateway. If you're having issues getting to something that you're pretty sure is public, check your security groups, check your NACLs, your network ACLs, excuse me, and yeah, make sure there is an internet gateway.
Nice. Here's a question that will test us, test our memory anyway. What is the retention time of a message in an SQS queue?
In what fashion?
So that it retains it in the queue.
I mean, it will stay there, I guess, until you kick it out. You probably can also set that number. I can't tell you off the top of my head, but it's something we could email out. One thing that is fun to talk about, though, is there's a timeout period on a message. So let's say you have a bunch of consumers that are all trying to eat messages at the same time. What happens if they both try to poke the same message? Well, one of them got there first, because although race conditions can be scary, And once it opens the message, it has a timeout that you can set on it where no other consumers can try to gobble that thing up.
And that's the invisibility timeout, isn't it?
Yeah. So that's always fun.
Yeah, that's a good point actually, because that might crop up. The questions. Does the Elastic IP assignment reflect in CloudTrail?
Does the Elastic IP assignment reflect in CloudTrail?
I imagine it would, because it would be an API call being made to associate it with a new instance. But I would have to check on that.
I would bet dollars to donuts it does, because that's definitely something that would show up if somebody did it in the console or via API.
Yeah.
But that's one of those strange things that you've never tried it, and so you don't know for 100% certainty. Or at least I've never tried it to check.
No, I've never tried checking. Okay.
How about the durability for EFS? That's a fun one. So only recently did EFS actually get an SLA around its availability, which I found particularly interesting, which they finally put out there, which is I think it was 3 nines. The durability is questionable, I guess. So keep that in mind. I imagine it's good, right? It's probably at least 4 nines, but it's not something I was able to find publicly. So sorry about that.
What is the difference between a NAT instance and a NAT gateway? I think because the NAT instance came out first many years ago, and the NAT gateway offers more flexibility. I think there's more security around it, and it's a managed service as well. So with a NAT instance, you have to create the instance and set a number of configurable components. You have to disable certain things. I can't remember off the top of my head. But with a NAT gateway, it's just automatically provisioned. We do have, I think I wrote a blog post on this, or a course that discussed the difference between a NAT instance and a NAT gateway. So I'll try and dig that out and provide some feedback on that. But there is basically the NAT gateway is the more advanced version of the NAT instance. It's now a managed service.
And what I would tell you from coming from the AWS side is the messaging now is like, do not use the NAT instance. Use the NAT gateway. It will save you a lot of time and heartache and pain. And it will save AWS a lot of time, heartache, and pain. And in general, it's better for both parties.
What's the difference between a Bastion host and a NAT gateway?
That's a question for someone with slightly stronger knowledge in that arena than me. But what I can tell you is they're very much similar in many ways. I don't want to overspeak my knowledge, but you can use them to avoid people directly logging into a machine. So a Bastion host could be used to obscure your backend IP addresses. Let's say you had a database that needed updates. It could first terminal into the Bastion host, and then through the Bastion host, go and find whatever it is that it needed to talk to. And that instance operates in the same with the same idea in place. But the routing might be different. And again, I could be talking out of my knowledge here.
Yes, so both Bastion host and the NAT gateway will reside in the public subnet. So the NAT gateway is used by your private instances with a private IP address to access out to the internet. Say, for example, an OS update, whereas the Bastion host allows perhaps your engineers access into your VPC from externally. They will jump onto the Bastion host first, and this will be a hardened instance with lots of security around it. And then from there, from that Bastion host, they will then be able to proxy off of that into your private instances within your VPC. So it's a really hardened host, only allowing specific access from specific IP addresses usually, with lots of additional controls. And that's how people externally can get into your VPC to carry out support or resolve issues, example.
See, that was a lovely answer. That's why there's 2 of us.
Okay, so we've kind of hit the hour. So I just want to highlight again that we have our AWS Solutions Architect Associate Learning Path here at Cloud Academy. It's designed to take you through every element of what's required to help you pass the certification. It's got 35 courses, a number of hands-on labs, different challenge labs, some blog posts covering different topics, and a preparation exam as well. So if you haven't taken a look at that, please do take a look. It should help answer any other questions that you may have. And so again, I just want to finish by saying thank you all for joining us today. A special thanks to you, Will, for joining me to cover the topics across Domain 1.
Of course.
Yeah, thank you. I hope you managed to find benefit from the content we shared. It could be used as a useful study aid before you take that step to sit the exam. I look forward to part 2 in the series, where we shall be discussing Domain 2, designing high-performing architectures. Do you have any closing thoughts, Will?
There's one question I do want to answer because it's driving me nuts. What's the Windows alternative for EFS, as NFS is Linux specific? There is one for Windows. I think it uses Lustre, if I remember correctly. Sorry. Want to squeeze that one in.
So other than that, do you have any closing thoughts?
No, this was a pleasure. A lot of the times, if you're looking for the answers on the tests, it's usually the one that uses AWS. So go with that. That's the best closing thought I can give you. That sounds silly, but it was before.
Just as we close this webinar out, there will be a quick survey. If you wouldn't mind just answering a few questions there, that will help us to enhance any future webinars that we may give as well. And don't forget to check out all of our other webinars, which you can find on our website at cloudacademy.com. And if you are on LinkedIn, which I'm sure most of you are, then we do have a Cloud Academy LinkedIn group, community group. So please take a look and join that as well. So thank you again. Thanks for joining. Thank you, Will. And I look forward to speaking to you guys again soon. Thank you.
Bye.